All right, class, so this is going to be the second part of our P5 notes videos, the second video. So we just talked about what a relation is. A relation is a set of ordered pairs. We talked about what a function is. A function is a relation. By the way, there's a typo right here. There should be no S there. Is a relation where there is no repetition in the domain. So we went over that. And the next big thing is function notation. Okay, we talked a little bit about that when we introduced relation, but function notation is, again, it's just a way of writing higher math notes. Okay, so in algebra 1, algebra 2, we use x and y. In pre-calculus and beyond, we use f of x. Okay, so I am missing in f right there. Okay, that's the same thing as y. That's the y value. Okay, so your y is just being replaced by f of x, h of x, whatever we want to use for the function. Okay, but they're, again, exactly the same thing. Okay, just writing it differently. All right, so the big thing associated with function, functions is domain and range. They always ask, what's the domain? What is the range? That's always, one of those questions that will be always asked if you are studying functions. Okay, so the domain are basically your domain is the set of all x values. Okay, for that particular function, they are the inputs. Usually I tell the students, can you answer the question, what can't x be? Or sometimes, can you answer the question, what can x be? This is usually not usually, but always your independent variable. Okay, so your domain, your x values, your input, what can x be, what can't x be, what is the independent variable? Where do you look on the graph? You look from left to right. Okay, so on the x-axis. Okay. So a very big thing here on the graph. Okay, so just look left and right, and that will give you your domain. All right, the range is your y set of y values. It is your outputs. Again, ask the question, what can't x be? What can't y be, or what can y be? And it, again, depending on the function, sometimes it's easier to answer what can't y be, or sometimes it's easier to answer the question, what can y be? Okay, so you will, as you do more of these, you will know which one to answer. Okay, and we will go through a few examples and you'll see that. And this is basically your dependent variable. All right, and on the graph, if you want to find your range, you look up, down. Okay, look up, down on the y-axis. Where is your function defined? Where does it start? Okay, what's the lowest value? What's the highest value? Does it go forever? Okay, so those are the two big words: domain and range, always associated with functions. All right, so here we're gonna do some examples on how to find the domain and range of some functions. Okay, so here you have here's in set notation, you have a function here, and it's given to you as a relation in set notation. And so here you have the 0.24, the 0.42, the 0.81, the 0.91. The domain is, again, just the x values. Okay, so domain right here. All right, that's your domain. These are the x values. Okay, and again, notice how it's written. Okay, so you have your domain there. Sometimes they use a colon, sometimes they use an equal sign, but it's always inside braces, and the numbers are separated by commas, and we are always putting them in ascending order. Okay, from least to greatest. All right, and if you have repeated ones, I would like you to write it down, because a lot of times they don't, unless you have a mapping, but you should always write down all the numbers so you see that there's actually a repetition. Okay, and for your range, again, the range is just the y values. Okay, so that's your y value, your y value, your y value, and your y value for those points. So domain, again, what's the x values? Your range, what are the y values when you're giving a set? One of the easiest, quickest way to tell the domain and range is when you know the graph of a function, that you don't have to do any algebra. You can just look at the graph and you will know what the answer is. Okay, so we don't even have to think about this one here, because in order for them to ask you, what is the range and the domain of a function, that means it's already a function, so we don't have to worry about those things down here that are not functions. So in I'm gonna call this 1 or A, call this B, call this C, and call this D. In graph A, you have a quadratic, okay? So then we are going to say, what is your domain, okay? So your domain is look left, right, okay? So we are going to be looking at where is your graph defined, okay? So is there a hole? Is there, does the graph keep going forever, okay? So the domain for A is all real numbers, because if you keep going to the left, that graph is just going to keep going. If you go to the right, that graph is just going to keep going, okay? So the domain for number 1, or A, is all real numbers, okay? So did we write that nice fancy R? Or you can just write down all real numbers. Okay, your range is, by the way, all of this is also in your common function graph worksheet. Okay, so if you memorize that, you have your answer right there already. Your range, now we're going to look up down. Okay, so we're going to look up down for your range. So it looks like this graph starts at 0, okay, and it keeps going forever. Okay, so your range, it starts at 0, and we use Y for range. So it starts at 0, and it includes 0, okay? You see here, that's that close point right there. So your range is all the numbers equal to 0 or bigger, okay? So that's the answer for A, all right? For B, you have a straight line, okay? So you know that a straight line, again, if you remember this from your common functions, you know it's all reals, okay, for both domain and range. But let's take a look. So if I were to do this, okay, if you look across the x-axis, that line is just going to keep going in both directions. So all the x values are part of your domain. And the same thing is true when you go to your y values, okay? Again, it's going to keep going. And so that's why we have all real numbers for both the domain and the range. Okay, so this one here, domain, is all real numbers. Same thing for your range. Okay, C, okay, again, if you will look left, right, okay, this graph is going to keep going forever. So your domain is, again, all real numbers. And if you look up down, again, this graph is going to keep going forever. So it's going to be all real numbers also. Okay, so here you have domain again. Oops. All real. And your range is also all real numbers. All right, let's take a look at D now. Okay, D looks like it's a semicircle, half a circle. And if you look, that graph starts from -2 and it goes to +2 on the x-axis, and it stops. Okay, so that means that your domain is only between -2 and 2, including 2 and -2. All right, so we write down x, we put a -2 here and a +2 there, and it includes both of those values. Okay, and your range, again, you look up down now. Up down is right here. Okay, so if you look up down, your range, we use Y for range, starts from 0 and it goes up to 2. 0 and 2, and it includes 0 and it includes 2. So that would be your domain and your range. Okay, number 3, equations. Okay, so how do you know that an equation is, or a function when it's given to you as an equation is a, how do you know, how do you find the domain and the range when you have an equation? So first of all, knowing your parent functions and knowing the graphs and the equation of those parent functions comes very handy. If you look at number A, right, and you know that that's like a linear function, okay, we know that that's just a linear line with a slope of 2/1 in y-7 and -1. Okay, so when you graph it, you just get a straight line, and we already know the answer to that. A straight line, with a positive slope will always have a domain which is all the real numbers. It's defined along all the real numbers, x, and the same thing for your range, again, all real numbers. Okay, if you look at the square root function, earlier I gave you something that looks like this. This is the parent function, and this is why it's important for you to learn your parent function, because the only thing different from this and B is that there is a -1 right here. So what does that -1 do? So if you know your parent function, you will know that it is a graph that looks like the parent function. But now with the -1, this same graph is going to be just shifted downward by 1 unit. Okay, so it's going to be starting here instead. Okay, and it's gonna then the shape is exactly the same. All right, so if you know that, then again you will also know that there's really nothing different, except that your domain would still be the same, but your range would change because now it starts at -1 and not at 0. Okay, so first of all, the domain for let's see. Oh yeah. So first of all, you should know that you cannot divide by a 0, or if you have a square root, that radicand has to be 0 or bigger. Okay. So just by looking at the graph already, you know that your domain has to be all positive numbers. Okay. So your x has to be equal to 0 or greater. Okay. And your range for B, again, it starts at -1, okay, and it keeps going forever up, okay? So your Y will start at -1 and it keeps going, okay? So that would be the answer to B. All right. So so many typos, sorry about that. C, okay, y equal to x minus 2, and then we want to square it. So for this one, again, it is your quadratic function, okay? So if you just know that, okay, your parent function starts right here. So once again, if you have that 2 there, what it's going to do is it's just going to shift your graph to the right by 2 units, so it doesn't change anything, okay? Your domain and your range will still be the same, okay? So your domain for this one, from your parent, your common parent graphs, okay, is all reals, and your y function is just going to not y function, but your what did I put y down? I meant to say the range. It's too early in the morning. The range would be everything equal to 0 or greater. All right. And this last one, you have your inverse function for D. Okay, just know that you cannot divide by 0, and this is answering the question, what can x be or what can't x be? If you already know that you can't divide by 0, ask yourself, what's going to make that denominator equal to 0? Everybody will know that -3 plus 3 becomes 0, so x cannot be equal to -3, and that's basically your domain. Okay, so your domain is all real numbers, but x cannot be equal to 3. All right, and your range, okay, your range, again, it's everything but 0. Okay, so if you remember your graph looks like this, and it's going to look like that still, except it's being shifted left 3 units. So your range will still be everything, but y cannot be equal to 0 because we have a vertical asymptote at y equal to 0. All right, I'm going to stop this video here, and we will pick up on number 10. What is the vertical line test, and how do you use it? Bye.